Welcome to the second video for this section. This is still on types of chemical reactions. This time we'll be discussing what are called single replacement and double replacement reactions. But before we get to that, we really should review our goals. And here are the list of the goals. You should know what reactants and products are. You should understand what a chemical reaction is. You'll need to know the four possible states of the reactants. And we're going to continue identifying reaction types. Remember that the reactants are the chemicals that will undergo the reaction. You end up with the products, and the reactants react to produce the products. The reactants will always be to the left of the arrow, the products to the right of the arrow. The hallmark of a chemical reaction: the chemicals you start with are not the chemicals you end up with. Four states of reactants: solid, liquid, and gas, each of which is a pure compound. And then aqueous, where the reactant is dissolved in water, but the water is not part of the reaction. And here's an example showing the four states of reactants: aqueous hydrochloric acid, solid sodium hydrogen carbonate, and they produce aqueous sodium chloride, liquid water, and carbon dioxide gas. Remember, there are 5 types of chemical reactions: the composition, sometimes called combination or synthesis reactions that we discussed the last time. Many reactants become one product. The opposite, decomposition. One reactant becomes many products. Today we're going to talk about the single replacement reaction, the double replacement reaction, and in a subsequent video we'll talk about combustion reactions. A single replacement reaction is very simply an element and a compound rearranged to make a new element and a new compound. The generic form would look like this: C plus DE, where C is an element, DE is a compound, becomes CE plus D. An example: solid zinc and aqueous copper 2 chloride will react to form zinc chloride, which will remain aqueous, and you will have copper solid being formed. Another example: solid iodide, if mixed with aqueous cobalt 2 chloride, the iodine and the chlorine will rearrange, and you'll end up with cobalt 2 iodide and gaseous chlorine. Another example is solid zinc and hydrochloric acid, which is aqueous, will react to make zinc chloride, which is aqueous, and hydrogen, which is a gas, and you will see bubbling through the water. And I happen to have a quick video of what that looks like. So that was zinc and hydrochloric acid as a single replacement reaction. Double replacement reactions: an ionic compound and a different ionic compound rearranged to make 2 new ionic compounds. This is the generic formula. Essentially, the cations switch places. You then rebalance the ionic charges, and you get your new compounds. When a double replacement reaction occurs, one of 3 things must be produced, though all 3 could be produced. The 3 things are a solid, which is sometimes called a precipitate. As a matter of fact, most of the time it's called a precipitate. And or a liquid must be produced, and or a gas. So let's take a look at some examples. Titanium 2 sulfate can react with barium chloride, and they will produce barium sulfate, which is a solid, and titanium 2 chloride, which will remain aqueous. What you would see here are 2 clear liquids being mixed together, and then a whitish solid would appear in the liquid and would eventually float to the bottom. Another example: sodium hydroxide, which is a base, can react with hydrochloric acid, which is obviously an acid. And when that happens, the sodium and the hydrogen switch places, and you get sodium chloride, which will remain aqueous, and you'll have liquid water formed. You'll actually see the volume of the liquid increase. A classic example, and one of which I will show you a video of, is lead nitrate, which is aqueous, and potassium iodide, which is also aqueous. and they are clear, colorless liquids. When they react, you end up with potassium nitrate, which remains aqueous, but the lead iodide will precipitate out. It will become a solid, and it's actually a brilliant yellow in color. So here is a video of what that reaction looks like. So that yellow material is the solid lead to iodide, and this is, as I say, a classic reaction. So to review what we covered in this video, the hallmarks of a chemical reaction are what you start with and not what you end up with. You got to remember there are 5 types of reactions. You know the composition reaction, you know the decomposition reaction. We talked about the single replacement, the double replacement, and we will be talking about the combustion reaction. A single replacement reaction, an element and a compound rearranged to make a new element and a new compound. And so, for example, iron 3, which is solid, and aluminum chloride, which is aqueous, can react to form iron 3 chloride, which will now be aqueous, and solid aluminum. A double replacement reaction, an ionic compound and a different ionic compound rearranged to make 2 new ionic compounds. This is the generic equation. And here is a specific equation. Aqueous silver nitrate and aqueous sodium chloride will react to form silver chloride, which is a white precipitate, and sodium nitrate, which will remain aqueous. So now you know 80% of the chemical reactions. In the next video, we'll cover combustion reactions. I will also give you a checklist that will allow you to determine the type of reaction if you are given an equation, and we'll talk a little bit about predicting what the products of a reaction are.